Wow, I thought there was always one solution.
Horror.
So, for instance, for this equation with 4 solutions, isn't it okay to find just the solution x equals 0?
Well, it depends on what you mean by okay. Of course, finding one solution is not meaningless. And depending on the situation, finding just one solution might be enough. But isn't finding all solutions like understanding the equation perfectly?
I see.
Horror. Especially when there is no context of applying mathematics to something. Solve an equation usually means finding all solutions to the equation.
So, solving an equation is like completely understanding it.
Yes, exactly, that's the idea. Now, let's consider the cases where there are 2 or more variables.
S.
For example, an equation with 2 variables is like this, right?
Is this.
Can you find one solution to this equation?
Leave it to Nimacon.
Horror.
The sum should be 5, so... Oh, I got it. If x equals 2 and y equals 1, the equation becomes 5 equals 5, so it holds.
Right. And since this is an equation with 2 variables, x and y, the pair of values x equals y equals 1 forms one solution.
So x and y together play the same role as the previous single variable x.
Exactly. Good explanation.
Hee hee.
And just like this for equations with 2 variables, there are various patterns in the number of solutions.
It's complicated.
Horror. Don't mix up the number of variables and the number of solutions. Essentially, we're talking about how many pairs of x equals circle, y equals square that satisfy the equation are there.
Oh, that makes sense.
Horror. Now the first example. Can you guess the solutions to this equation?
Oh. If I can make all the terms on the left-hand side 0, it's okay. I got it. If x equals 0 and y equals 0, the equation becomes 0 equals 0, so it holds.
Good job, Nimacon. To sum it out, for this equation, there is the only solution you just found, Nimacon.
Nimacon. It's me.
Horror. Then how about this one?
Well, there are lots of x and y. How should we think about this?
Horror. Alright, here's a hint. At first glance, the left side seems complicated, but this part, and this part, and this part are all multiplied together, right?
Right, if we substitute x equals 0, y equals 0 like before, it becomes like this. So this part becomes 0 just like before. That means the left side consists of multiplications with 0, so it becomes 0. And the whole equation holds as 0 equals 0.
Is correct. If you think about it the same way, you can find 2 more solutions.
I see. The equation is satisfied also when this part becomes 0. So I got it. If x equals 0 and y equals 1, this part becomes precisely 0. So just like before, the entire left side becomes 0. And the equation is satisfied. As similarly, if x equals 1 and y equals 0, this part becomes precisely 0. So again, the entire left side becomes 0. and the equation is satisfied.
Yes, that's great. I'll skip the explanation, but all the solutions are found by you.
So, since a pair of the values of x and y is a solutions, there are 3 solutions: x equals 0, y equals 0, x equals 0, y equals 1, and x equals 1, y equals 0.
Yes, perfect.
Nimikong. It's me.
Let's move on to the next example.
Okay.
How about this one? There was a similar example when the equation had only the variable x.
Yes, I know this one. The left side has a multiplication by 0, so with x equals 0 and y equals 0, or x equals 10 and y equals 10, or x equals 100 and y equals minus 100. No matter the values of x and y, the equation holds.
Alright, so how many solutions are there?
Infinite. Like, x and y can take any pair of 2 real numbers.
That's very good. In more precise mathematical terms, the tuple xi can be any tuple of 2 real numbers.
So the tuple xi is like the pair of values of x and y we've been talking about.
Exactly, that's right. Well done, Nimikong.
Haha, Nimikong. It's me. This is going to be popular.
Now onto the final example.
Okay.
How about this one? There was a similar example with an equation with only the variable x.
This one though. No matter if the value of x is positive, 0, or negative, the left side always becomes non-negative. So there are no values of x that satisfy the equation, meaning there are no solutions.
That was the case, wasn't it? So what about this time?
I see. Just like before. No matter if the value of x is positive, 0, or negative. Whether the value of x is positive, 0, or negative. No matter if the value of y is positive, 0, or negative. This part will always be non-negative. So, adding 2 non-negative things, the left side will always be non-negative.
So what will happen to the solutions?
And, since no pair of x and y satisfies the equation, there are no solutions.
Exactly right. To summarize, even if there are 2 variables, there can be one solution. There can be multiple solutions. There can be infinitely many solutions. And there can be no solutions, meaning 0 solutions. The same is true even if there are 3 or more variables.
No matter how many variables there can be various patterns. In the number solution, that is, tuple of variable values that satisfy the equation.
Yes, you've understood it well. Hurrah. Oh, hello there. I'm Bulchen, a cute bear.
Hey there. I'm Nimikong, an even cuter bear. Hey there. I'm Nimikong, a cute bear too.
Hurrah. In today's class, we'll be talking about what equations are and what it means to solve equations.
Alright, got that.
First, when we say equations. For example, this expression is an example of an equation in terms of x. Using this expression, I'll explain what equations are.
I think I understand. An equation is an expression with x in it, right? On this expression, transpose 2, transpose 3x, and then divide by the coefficient of x, which is 2. And we'll get the value of x.
Exactly, that's the correct way to solve an equation. So what does that final value of 3 for x mean?
That's the solution to this equation, right?
Yes, that's right. Then what do you mean by the solution to this equation?
I am the all-knowing, all-powerful bear, Nemocom. Never thought about that before.
Oh. The solution to an equation for x means that if x has that value, then the original expression becomes true.
What does that mean?
For instance, in this original expression, if we substitute x equals 3, in other words, replace x in the expression with 3, what does the expression become?
The left side is 5 times 3 minus 2 equals 13. And the right side is 3 times plus equals 13. So it becomes 13 equals 13, right?
Exactly. So 13 equals 13 is certainly a true equation. So this equation in terms of x is correct when x equals 3, right?
Of course.
But